hit this guy over here. We have slides today, which makes it a good day, right? I think we're there. Give it a moment for the old Twitch feed. It's like kind of there. Be warned, the microphone.
No, I didn't say any answer or anything.
No. I don't care if you say an answer, but you're going to be like, oh yeah, man, just come over to my place at, 123 Main. It's like, man, don't dox yourself, please. Right? So today's 12/3, I think, of 2024. And we are in our last week here in the class, which is awesome. Our last module is System Security, which launched on Black Friday here in CSE466 at ASU. This is a great module because of all of the pre-recorded stuff you have to watch, right? There's tons of material that you can go through. There's nothing, right? This thing is entirely reviewed. But how have we done? So we finished micro. No, we didn't finish MicroArch, did we? All right. You guys got a reprieve there because everyone always stumbles through MicroArch. In particular, you run into this exact problem here of you're doing everything right on like level 5 or some of these speculative execution things, and you don't get the right answer, you don't get the right answer, you don't get the right answer. It's some insanely low probability of you actually getting the information that you want, which leads to everybody getting stuck on a level 5. The classic blunder of this module is you get stuck, and instead of writing good code, right, after 4 years, hopefully, of computer science study, instead of writing code that is efficient and makes sense, we're just going to increment a number on a for loop. And that changes nothing because the problem is your own. Yes?
Well, I tested this today, but during training, you could just have an if true and like have some arbitrary like set x equals to 0, and that would train your branch predictor and it would work.
So training a for loop, you can do that in a while loop. Yeah, I think I know what you're asking or where you're going with this. I'll rephrase and you can tell me if I'm right or wrong. All right. So some people, and it's not like a secret, we actually make these, despite what everyone like thinks of these challenges, ridiculously easy for you, right? There are challenges that go out of their way to train themselves. There are scenarios where the CPU may not even require training, right? I think some of the later ones are solvable without actually doing training loops, right? The CPU just like, yeah, we're going to guess that way. And that's just what it does. And that can make you think, oh, this whole training stuff is all made up, right? But it's actually intentional to try and make it easier for you guys to pull off the exploit. Is that where you're going with it? Kind of?
I know, or at least not level 5, since at least for the like level 10-ish ones, you could, instead of training the actual chat, like setting the index of the actual chance to train it, you could just train it by having a for loop and then if true and just some arbitrary like instruction, and that would also train the branch predictor as well as if you just set the index.
Okay. So what I talked about here, so I don't know what level was. Level 10 wasn't meltdown. It had to be a Spectre.
It was level 11.
11? It was 11 meltdown?
No, meltdown was 13, 14.
Okay. So when I talk about the Spectre, I try and keep things straightforward as like can be. But in the pre-recorded lecture videos, like I did allude to the global branch predictor, right? And for the people that were racing, I think it was level 5 they were racing. So far from what I've seen, the person who has the best time on level 5, the thing that got them better than the second place person so far is the fact that they did exactly that. They had a while true and then just constantly saying yes, right? Because while true depends on what happens in the assembly. That'd be interesting to take a look. But I'm going to envision that there is while true if something, right, is what they had.
Is there, well, when you say global branch predictor, is there a local branch predictor? Like,
So
I'm thinking there's only one branch.
no. So the statement for Twitch is there, what is this global thing? I thought there was just a one branch predictor that is the branch predictor. And the answer is, I'm not the right person to ask because I'm not an expert in computer architecture, right? There are courses at ASU which I wish I would have taken, computer architecture 1 and 2 that go into that specifically in detail. But my kind of hand-waving understanding here is that there's multiple things that can influence what gets chosen, right? Like when we talk about training in the sense of this module and kind of at face value, what we encourage you to do, which is run a for loop, go through it correctly or true 3 times, and then fire off with your falsy value to speculate. That is dealing with, I don't know that this is correct terminology, but I'll go with it because you hit me with it, the local branch predictor, right? And that is what is happening at that virtual memory address, right? There's also parts of the CPU that still are just simple state machines, but the state is influenced based upon larger patterns that are going on across the CPU as a whole, right? And that is kind of what we refer to when we say the global branch predictor. Because there can be higher level patterns than just what happens at this particular memory address, right? Well, imagine a scenario where we have some type of loop and then a conditional nested inside a conditional, nested inside a conditional, nested inside a conditional, right? Now, if I had just a local branch predictor, sure, I may be able to deduce the correct path ahead of time on some of these. But what if within this entire cycle of this larger iteration, there is a pattern of true, false, true, true, false, true, false, true, true, false, right? And then sometimes it's false, true, true, false. Well, like if you build a larger state machine on what are the patterns of yes, no that are occurring on the CPU, you can identify the relationships between those branches. And that is what the global branch predictor is able to detect, which does influence or bias what will be speculated. It's not necessary to do that, right? So the reason that the other person was able to save time, and maybe Twitch will say, because they're like angry because that's the second place person, yeah, you're not number one. But my understanding of how they saved time is they basically did zero training in their actual speculative code. So they didn't deal with the simple 2-bit state machine that we talk about in this class. Instead, they just had an infinite loop that was like, yeah, man, we're taking it. True, 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 to just bias the global branch predictor in another process as much as they could.
Oh, in another process.
In a whole other process. So they didn't even have the work going on inside their exploit code. So that saved them the CPU cycles of having to train, which is how they came out ahead, which I think is super clever, right? This class and this course as a whole isn't meant to be like an in-depth everything that you could possibly know about memory corruption or everything you could possibly know about kernel exploitation. It's like, hey, man, here's something cool. And it should be enough to where you can reason about it if you were to read, say, a more modern microarchitectural exploit, right? You read a write-up on it. Can you reason about what's occurring? You're not going to be an expert on any of these things. I'm not an expert on any of these things, right? I'm just familiar enough to where I could take a look at probably anything related to the topics we've discussed in this class and grok it very easily, right? And be like, okay, cool. I understand what's happening. That's the goal here. Especially when it comes to microarchitectural stuff, this is constantly changing. And so even when I say like everything, the local branch predictor is like a 2-bit state machine, that could change, in the future. So that's just CS, right? Everything is subject to change. Good question, though. Now, it goes back to like those unintendeds. I don't think we could stop that one. But I think unintended solutions are cool, right? I get to learn, one of the things that I enjoy about teaching this class is not only when people have unintendeds, and it's something I didn't think of, but also when people ask questions, like what you just did there. And it's not something I'm like, oh yeah, man, I know this inside and out. Because it makes me think about it. Like later tonight, I will look deeper into that myself, right? Gives me an idea of things to look at and learn about myself. So Yon 85 makes its return. Hopefully you guys wrote that assembler because you had that in MicroArch. And as people immediately realized, you have that in system. So hopefully you have that assembler. That'll pay off. In general, though, like grades are posted, right? There's no more assignments. There's nothing going on there. That's what I should have done. I should have made a grade slide. No dice for you guys today.
For Thursday.
Yeah, give something for Thursday. But yeah, all of the assignments that are in the course are posted, which means whatever the grades page says your grade is what the grade will be if you do nothing else. I know this is the last week of coursework officially for ASU. So hopefully you know how things are going to go and how much effort to put in. Typically, students do not put in a ton of effort on the last module. They go do finals. I understand. Do what's right for you. Because you will struggle to figure out what it makes sense to spend your time on, whether it's this course or even modules within this course. The later ones, like system exploitation, is cumulative, right? It's going to involve reverse engineering, Yon 85, kernel, probably some shell coding. If there was a shell coding challenge that you could, 2 shell coding challenges you could do in half the time, it's equivalent to the whole struggle of one of these cumulative challenges. That's probably not entirely true because the challenge count isn't the same. But it may make sense to go back and look at the end modules instead of the stuff that's currently live, even though you only get half credit for doing so. And as I said at the beginning of the semester, the meme extra credit will ultimately pay off. Hopefully you feel that right now, because it will save your grade. Logistics. So next week is finals week, which means that the schedule for all rooms and everything changes up. I cannot be here in this room. I will try and do live streams myself on Tuesday, Thursday, same scheduled time. This may or may not be on Twitch. I may do it on Discord and do something that is much closer to like a office hours, hands-on type of thing to try and help people that are stuck on anything in the entire course, not just the current material. Yes?
You asked us to vote when we would have office hours this week, if we were going to have it.
So, okay, yeah, a good question. So it's not this slide, it's on the next one. We can hit it now. The TLDR there is, I think instead of doing office hours this week, and if you guys like aggressively disagree here, that's fine. I can't be on campus on Friday. So my trade-off here is like, okay, I'll do 2 live streams targeting 2 hours each on finals week, Tuesday, Thursday, same slots, be like 4:30 to 6:30. So you get more time and you get it spread out across the week. Is that a fair trade to you guys, or are you just like, no, man, it's finals week, I don't want to deal with anything?
I'm okay.
You're okay with it? All right, I got a thumbs up there. Like, see, it seems like a fair deal. All right. Like, if you're like, no, I really want something this week, like, I can try and find a place on campus on Thursday or something, but this seems cooler to me. So I may do it on Discord. I'm undecided here. If the reason I would do it on Discord is to make sure that it is unrecorded, so that way we can be a bit more fast and loose with what we talk about. It is the last week of class, since next week is finals week. So I will not be here for my office hours on Friday. There'll be no recitations with the TAs for finals week. Same reason, room schedules are whatever they are. So they are free. Some of them they don't have finals, so they're like not even here anymore. Belts. It's interesting. I think someone had to have earned some belt in this class, right? Maybe. You earned something? A yellow? Was that all you're gonna earn?
Maybe a green.
Maybe a green. All right, I want at least 1 green. All right, at least one of you should earn a green. So End of semester class recitations, grades page should be current. We typically do, not just for this course, but for all the pwn.college courses, a live stream belting ceremony. Somebody asks, what's the current bell curve skew of the class grade? I don't know, but I'm sure it looks like the left half of a bell curve. If I don't count, well, yeah, it would have to look like exactly what I showed last week or the week before, because technically microarch isn't done yet, and neither is system. So whatever I include is all kind of wishy-washy, since everything else is due at the end of the semester. I'll try and show something on Thursday, but I'm sure it's a perfectly fine distribution to where it should be harder. Belting ceremony. We try and do a live stream here on campus where if you have earned a belt, and it's not just for this class, but for 365 as well, the instructors get together. We, have a little ha-ha. You can come up on Twitch if you want. We'll award you your physical belt. You don't have to earn all of them up to blue belt, just if you've earned it. I believe we've talked about doing it on Tuesday. I'll let you know for sure on Thursday.
So it's not cumulative. You can earn a green belt before orange and yellow.
The question was,
It's not.
is it cumulative? The answer is yes. So that means if you have not earned an orange belt, you SOL for the yellow and green. Like I understand, especially since 365 added stuff to the orange belt. So if you were like almost there, they just constantly added stuff and piled it on top. There was some poor person on the Discord I saw where they were like, every time I solve a module, they add another one. So I understand, but there's always next semester. Right? We do the belting ceremony every time. And if you are an ASU student and you don't want to be on stream, like the ceremony isn't important, you can always let us know and we'll give a belt to you off stream. You just don't get that preserved on the internet forever. End of semester surveys. I believe, have you guys gotten a survey from ASU?
Yeah.
They usually send it out around this time, where they say, hey, review all your classes. That is for ASU. I do eventually get to see it, but it's like months after your grades are submitted. So feel free to be as brutal as you want. Hopefully it won't be that bad. I had mentioned that I will blast out a Google form soon, TM. I have started making it. It'll probably get sent out later tonight. I'll finish working on it. I'll just put it in the announcements channel. I originally said that it was not going to be anonymous, and then I'd give you extra credit. I was like, well, that's kind of lame, because I want real feedback from you guys. And I do get to see it before I post your grades, and I don't want you to be scared. So I will make it anonymous, and then just everyone here gets 1% extra credit. I added that right before I started the stream. It's on your grades page. Congratulations. But please still fill out the survey, right? When I do send it out. I would greatly appreciate it. All right, demo time. For whatever reason, didn't we talk about this before the holiday? mmap? Or I'm hallucinating.
Yeah, we did. You just told it.
Okay, so
I mean,
we didn't successfully call mmap, but we were like, yeah, mmap exists.
You just told us what it does and how it affects files on
All right.
system versus on
All right.
disk.
Okay, that's fair. I don't know if this is right or not. We can give that a shot if you want for level 1. We can take a look at level 1. And then somebody asked about level 3. Oh, the name's not the same, but you're calling me Mr. Robert. What was the deal? The deal was I'll look at level 3 if you don't call me Mr. All right. Somebody else asked about level 2. If their IDA skills aren't working, what's the best way to debug? Do not use IDA to debug. Come on. Do you guys have anything? Yes.
I just had a general question about how to send the shellcode in one. I was talking about it over in Discord, but I saw like various ways of doing it. The way I'm doing it now, and I'm getting issues with permissions, is I'm mapping some memory, and then I write some YAWD code and copy it to that memory, and then I octal to a file descriptor that is the file descriptor of the device we're supposed to write to.
Okay.
And I open that device by opening up a separate terminal
Why?
and running the challenge. Because, well, I can't open a device without sudo permissions. Not that I can't open the device, but I can't write to the
The
device.
challenge opens the device for you.
Right, but when I try to write to the already open FD, I'm not able to.
Are you sending?
Why are you okay? Well, we'll take a look at level 1, and when we get to various points,
Yeah.
let me know, and we'll poke at it. All right. Because doing mmap, it's part of the challenge, but it's not the crux of the challenge here.
That much I understand, yeah.
No, but like we'll successfully call mmap, hopefully. Hopefully I can do that in 45 minutes. And then we'll try and reason about what's going on there. So one of the things that you said that kind of worried me is I'm spinning up another terminal. And I caught some of the Discord conversation, but I didn't want to chime in because it gives me stuff to talk about now. And one of the questions was, can I open up a file descriptor and have it accessible in 2 terminals? Right? Anyone want to answer that and say why? This isn't a trick question. This is like first principles. We've definitely discussed it.
Can you repeat that?
I said it's first principles.
That question, like,
Can I open up a file descriptor and have it accessible in 2 different terminal windows? Say again? If I don't close it.
We can open 2 terminals using script and pass through those file scripts.
The same process, right?
So
the same process.
they are different processes, right? If I open a different terminal, right? When I launch a terminal, what am I calling? What program's running? Bash, right? Typically, there are others, but it's just bin bash. And so if we were to PSA-UX F, we see here's my bash that called bash that then called PSA-UX F, right? If I were to open something in that parent bash and then spawn the child bash, what do we know about file descriptors? They're inherited. So the parent would have it, the child would have it, right? So could I, it's not what I would do, and I don't think it's necessary to solve level 1, but I think it's an interesting thing to think about here. Could I create a scenario where I have a parent process that then spins off 2 children that are terminals? Yeah, I could, right? I could open something up, fork off a bash instance, that would inherit the file descriptor. I could fork off another bash, and it would inherit from the parent the file descriptor. So at face value, I can do that. I typed exit because I just exited the child bash. I'm back into the parent bash. Because generally speaking, you don't want to nest a bunch of bashes. So you definitely can do that. I don't think it's necessary for this challenge. So let's take a look at it. In IDA. We're not going to use IDA to debug. What level is this? This is, I think, 1.0. Yeah, Twitch made a few observations, but we have to discover it for ourselves, Twitch. So I have a userland, and I have a kernel module. We mash tab here. What do I got? Welcome to so-and-so. You can upload some custom shellcode. It opens proc YPU on some file descriptor.
Oh, yeah.
What's up?
Oh, the YPU is a typo, but they meant to proc you.
Proc U?
Yeah, then I realized the yarn processing.
Oh, you got the joke. Which once you get to level 3, you get multiple YPUs. Yeah, you get more than you need, but better than insufficient. Then it calls mmap. What is it calling mmap on? Does it use the file descriptor? No. Okay. Mapped whatever bytes for shellcode at p. Oh, okay. So that's calling mmap to get our shellcode. Reads our bytes of shellcode. Cool. Challenge about to execute our shellcode. Shows us to us. Call setComp. We're allowed to call mmap and ioctl. And then we are set free. Okay? Anyone have any questions about what this thing does? All right. So it creates a region of memory, reads in some shellcode, and it opens up the kernel device at proc YPU. And then we can only call mmap and ioctl. Let's take a look at kernel module here. Today I learned PS has an F option. Only some PSs have an F option. On Mac OS, you can't use -F. Fun fact. All right, we got the init module. It's just going to print off some stuff. It's going to make this YPU. On device open, it's going to mmap. Now, this is not an mmap call, but it's functionally an mmap. I think I said this last class, where it is mapping a region of memory to the private data, and that is shared across all of these various entry points. Now, if mmap is called on the file descriptor that is exposed by the kernel device, it's going to give us that region of memory inside the kernel. And then the last thing I'd be interested in is what happens if I call ioctl, because those are the only two things I can do. Let's call mmap and then call ioctl, right, based upon this challenge. When I ioctl,
It's down.
it's down, it's down. Okay, okay. When I ioctl, what do we get? While v3, okay. It's going to loop through and zero out some memory. It's going to print something. What is it going to print? Device ioctl, blah, blah, blah. If the command number of the ioctl operation is 1337, we call interpret instruction, which we've seen before, is a Yarn code interpreter. Okay. Where are the instructions here? I look at interpret instruction. That's going to be this V9. V9 is V8 arg1. V8 is state code.
I think it's at the top for the command. Yeah, the state is the address of state.
Okay, yeah, so that's my initial state. What I want to reason about here, there's what I'm looking for. Private data, private data. Okay, I was trying to find, I was almost there. I was trying to find where the Yarn code bytes are, right? From reverse engineering, I obviously have some passing familiarity with these challenges. But we've seen interpret instruction, and so I was like, okay, well, where are these instructions? There's the state, and then the state's code is the private data. And that private data is from the file private data, which is that same region of memory that we get from mmapping. So we can write Yarn code bytes into this thing. Everyone agree? All right. So, what do I want to do? Well, the first thing I want to do is I want to VM connect. Otherwise, we have a very bad time. Ah. It would have been, wouldn't it? You know, you got to try. You got to try. Okay, let's see. Oh, we got some engagement today. What do I got here? other completely unrelated to this challenge, but fun thing for file descriptors and terminals. So you're familiar with the concept of like a network socket,
Yeah.
right? So on Linux, there's something that's known as a Unix socket, which is a way of doing communication between processes as well, except it's all local. One of the cool things about Unix sockets is you can pass file descriptors over a Unix socket from one process to another. All right. That would be like way over engineered if you wanted to try and do that. But you could do it. Fun fact. Was that Unix? Yeah, most people don't use Unix sockets. The Dojo infra does quite a bit though.
This may go down a rabbit hole, but what if there's a conflict? Like I file descriptor one on one process points to something and some other process sends another file descriptor one.
That's a great question. You know where the answer is going to be?
Command.
Oh, you see, the one thing I wanted you guys to learn. All right, you had to learn either GDB or the answer is to read a man page. I think most of you, I got you for both. Yeah. I think I might have made my life a lot harder by using Binja instead of IDA to decompile the module when I solve these. IDA has better info on structs. Maybe. All right. So I want to interact with this old challenge. All right. It opened it on -1. Yeah, you know, you fell into my trap. All right, it works. FE3, we're reading some stuff, we rock and roll. Now, one of the things I saw in this conversation was I want to write this in C.
Yeah.
Why?
Just because it's like easier to write out.
Because there are mmaps and it's easier to handle addresses in C than in Python.
Well, that's no. You said shellcode in Python.
So this, I want to say there's another challenge. It's not this one, but there's a meme that you guys didn't do this semester, and I think it's about this one, and it's one of my favorite memes. It's I'm hiding shellcode in my shellcode, right? Like that's kind of what this one is. Like, yo, dog, I heard you like shellcode in your shellcode, so I did that. That's what we're doing here,
Yeah.
right? And do I have a do.py? Oh, that's bad. I'm in the VM. All right, you get out of the VM. All right, I don't want that do.py. We'll make a new do.py. I believe in Python. I think MicroArch is the only one that you needed to really use C. Because ultimately what all I have to do is pass shellcode into this thing, right?
If you run Python in the VM, it takes like a minute for Python script to go.
That's true. Yeah.
Okay.
So usually you could like use Python to write the shellcode to a file and give that file to the child instead. That's a lot faster.
Like a document.
That's fine. Okay, so you don't want to have a process. You know what? I still want to have a process. I understand what you're saying. All right. At face value, I'd want to do something like this, and then I need to build my payload is going to equal ASM, and I need to do these things. Now, way back at the beginning of the course, we had this shellcraft thing, right? What does it do?
It generates shellcode for like cat.
Automatically write the shellcode for you.
It runs Gmail processes.
Right? It solved the challenges. It got me the flag.
No,
I think there's a yawn, so
If only it wouldn't surprise me if there is. Somebody says C is love, C is life. Yeah, C is great, but here I don't think we need that. So there is, in fact, a shellcraft mmap, right? And so I may be like, okay, well, how's this thing work? And we can take a quick look there. It's going to take an address. Is it constant inside this challenge? Yes, it is. Find out if this works. Length. How long is this thing? I agree.
Yeah.
Okay. How do I get this? So you say I want share. How do I get that?
X22.
How did you get that?
Looking it up, Google.
There's like a dictionary in Pong. I don't remember. So, yes, constants. So,
I can't see.
It says 1,
Oh, okay.
but you said 22.
But it's I combine map shared and map populate. That's 22.
Okay. So let's take a look there at this thing. It wants protection and then flags. And then if we take a look here at mmap, what do I want for protection? Is that where this comes into play? It's not. So I need to open this up for what? Read write?
yeah.
Cool. So let's up here in my script just say protection equals constants protect read ord with context or constants protect write.
I guess might be wrong.
Yeah. Well, I mean, we could keep Googling and guessing things, or I could write code that's pretty explicit about what I'm doing. And if it doesn't work, it's very, very clear what I am doing. So read is 1, write is 2, and yes, if we order them, I agree that would be 3. But I didn't have to know that it was 3, right? And then if I were to pass this script to somebody who has never watched any of these lecture videos, there's a chance that they could identify what is happening there, right? Versus if I just said, yeah, proc is 3, right? Make it easy. Make it easy for yourself.
Comments. I will defend myself here. I did add comments. But,
You added okay, all right. Comments are good.
This is a better way to do it.
All right.
Definitely a better way.
No, okay. But believe me, I'm not all best practices, but I think this is a pretty good one.
No, that's good.
All right. So the other thing I need is that flag value. This is where you wanted map shared, right? So let's put that guy there. Flags will be constants, map shared. Do I want anything else? What did the meme say? Let's have the meme guide us. I've been signed out. All right. The meme says map anonymous. What? Oh, you say no.
I don't know about map anonymous, so I'm sure map private is not right.
For sure map private's not right. Okay, so you don't trust the meme.
Also, it has exec, not exec.
It also has protect read, protect exact. Okay,
Also
so
using a -1 as a file descriptor.
Not file descriptor. Yeah.
Oh no, it's
Never
never
had.
it does have -1 there, but that isn't necessarily for a file descriptor, right? This is where the main page is our friend.
Right.
The first value is an address. And if we were to read this, I used the same value that the challenge was using. But what this address is a suggestion, right? It says if the address is null, then the kernel will choose where it's going to map this stuff. Inside the kernel, it may be 31337, but in userland, it could be, I don't know, 12,000, right? It doesn't matter. Both of those virtual addresses point to the same underlying region of memory. Just because you said this won't work. All right.
Well, I said thank you.
I think it will. Okay. And then what was I could be wrong. I didn't dry run this. Like let's have some fun.
You need the file descriptor and an offset.
Okay, file descriptor, we saw down here in the challenge should be 3. Offset, we'll go with 0. Is that a reasonable number?
You don't need
I don't need 0?
semicolon.
Oh, yeah, I'm writing C Python, kind of. All right, what is the return value when I run this? What does this give me?
I don't know what took.
No, nobody knows, which is a good sign. It means you didn't. Let's do. Huh. That makes sense. So it gives me
Instruction.
text.
Context. Yeah,
Right? No, I didn't set the context, but that's fine, right? We could reasonably guess that if I set the context up in my script, I'll get 64-byte shellcode when I run this thing. Or we could just do it. And we see, all right, I don't care how I had to call it, right? This is what happens. And so there is my mmap shellcode. Going to make this a f string, and inside of it, I'm going to put my mmap shellcode. It's just going to take that text and put it right there. All right, what else do I want to do?
Pass YARN for the shellcode.
I want to pass Yon85 shellcode into this thing. How do I do that?
I have to. Oh, that's how you communicate. No.
I can ioctl, but ioctl, when we take a quick look here in IDA, ioctl is how we made the machine fire. That's how we get interpret instruction going. Right? So I probably want to do that. So we can figure out the other stuff later if you want. All right, let's do the ioctl. So what assembly do I need to write? Oh, we're learning. Shellcraft .ioctl. Okay, that exists. What do we want to pass to this thing?
Find the descriptor of lighting.
Question mark. You said 3.
1, 3, 3. So it's just 1, 2, 3, 7.
The request is this hex?
That's 1, 3. No, I remember it. What? No.
Where am I? I'm inside ioctl.
That's right.
It's command. This is an int.
It's 1, 2. Yeah, yes.
Sorry,
It's 1. Yes.
decimal. Okay. Then what?
Do we need passage?
Oh, you tell me, man. I got this arg thing. This arg thing's the other thing, right? That's my third argument.
No, we don't need
If I leave my cursor on it and we scroll down, do we see the yellow?
no, we don't use ARM.
Okay, we don't use it, so I really don't care how Python interprets this, right? I really don't care about C types. It's just going to be 0. Makes sense? Now, some people recognized that if I do this, let's not have some garbage in there. This is going to take a minute. Am I in the VM? Yes, I am. Maybe it'll blow up, but hopefully it works, and it just takes a minute. Someone says you can pass registers to shellcraft as strings. Yes, you can. And so that is kind of lame. Oh my gosh, it looked like it worked. It didn't even blow up. Okay, we seg faulted. Right, I didn't exit, right? So we kept executing our shellcode. We got down here, we seg faulted. Doesn't mean anything bad happened. So I'm not going to be worried about that. But that took a minute. So let's not do that. See, I use comments too. So what do we do instead?
We write the shellcode.
Okay, we're going to write the shellcode to a bin file. How do I do that? How do you want to do that?
Right?
open.
Yeah.
With open. What?
Right.
With open SC?
SC.
Okay.
In right bytes WW
WB.
as F host.
Okay.
F dot right. Payload. That's it.
See? Now, how many of you wrote tons of Python before this course? Oh, I'm surprised. I was like, look at you guys go. Look how far you've come. So now I'm outside of the VM. I can run my do.py. That makes my payload become this shellcode file, which I can then pass into the challenge. How do I pass that into the challenge? What? Oh, you want to carry it in? Oh, you guys are awesome. You didn't even say like cat it. That's what I would have done. Would have been a useless cat.
I would have written a C code to open that file and send it to.
I would have written a C program to open it and pass it in. Like, okay, I appreciate the honesty, right? But let's make things as easy as we can here. Okay, so now we have hopefully a working skeleton of what's going on. Now, to circle back to the Discord conversation, the kind of original question was, can I have a file descriptor open in 2 terminals, right? Do you still think you need that based on what we've seen?
No, but
Okay.
now I'm trying to understand how we patch shellcode like with this method. So I'm trying to
Pass shellcode or yarn code?
beyond good.
Okay. No, you're good. So the statement was, no, I think we can do all this in one process, which is my understanding looking at this thing as well. But now I'm like, okay, how do I get the yarn code in there? It's great that I called mmap, right? And it's great that I called ioctl. But how do I get shellcode into this thing?
And I came to this conclusion before, and I was trying to use the ioctl in the third arg, but then I looked now realizing that third arg isn't even used.
Okay. So yeah, that's one of those like classic reverse engineering blunders. Is like you make an assumption about how it behaves,
Right.
which you should do to make things quicker when you're reverse engineering. But when things don't behave how you would expect, you should rapidly reassess, like abandon prior beliefs.
Yeah.
Because it's easy to be wrong. So I didn't write all this shellcode, right? Phone Tools did it for me. But what do I know about anything that's going on here? So I know that this, I can reasonably assume this right here is my mmap call. Everyone agree?
Yep.
Okay. And this right here is my ioctl call. What else would I want to do here? Where do I need to get the shell or the yarn code, yarn bytes into this thing?
Yeah, see that.
To the address I am mapped. Where is that value? Where is it? How do I get to it? How do I get that address?
It's in the
What's the
return XOR.
Racks after this.
Right. The return value is in racks. And if we were to read the man page for mmap, we search for return on success. Mmap returns a pointer to the mmapped area. So at that point in time, right here, racks has the value that I'm interested in. Can I easily inject myself into here, between there?
No problem.
Yeah, I can write whatever I want right here. So what do we want to do? We want to put some bytes there. I have to figure out what bytes I want now. So now we have to go deep down the old yarn rabbit hole. Let's see. Now I'm just curious, since this is a 0.0, how do I get output? The message? All right. So we do get output here, and we see before I did anything, it's blowing up quite early with these bytes, which is just whatever happens to be there, right? We haven't actually written anything to that location. But just as a proof of concept, I could move into I don't know, RDX, do beef. I like beef. And we'll move into the address defined at RAX, RDX, and do the same thing. Yeah? Outside of the VM, we'll run our do.py. Inside of the VM, we will not do a useless use of cat. All right, we still segfault. Now we look at the D message. That looks the same.
You could have message follow open in another terminal so you can see what happens.
Okay, the comment was I could have dmessage following in another terminal. My problem is that this top window here doesn't really exist because that's my smiling face. So on the stream. So if I had it up there, Twitch wouldn't be able to see it. So I want to know, did my beef make it? Right? Well, let's see. You say it did? I don't think it did. That's sad.
We wouldn't go through all the instructions because it would crash.
Well, it would still crash, but I should see.
You would see it.
Hey, I should see it up here. Well, as it's printing.
Continue the rest because the instructions are invalid. So,
But it's not John.
yeah.
Right, I don't care that it's Yarn code. So I'm looking at this debug output, right? A Yarn code instruction is 3 bytes.
Yeah.
Okay. I right here, if I had beef, which is 2 bytes, we'll just say beef 0. I should be able to see in op 0, the first interpretation of where it starts interpreting, right? I should be able to see, I don't know which one of these, but I should see B, E, E, F.
Yeah.
And I don't. So I'm doing something wrong here.
Yeah.
Oh, it's the like map thing that you change.
Oh, okay. You wanna maybe you wanna
I agree.
Because you want to share.
Map shared and I see.
you want something else?
I also use map populate.
Constants.
All right, we build it. We do it. We demessage. Do I get the beef? Oh,
Yeah.
there's beef.
Okay.
There is beef. All right, where'd my beef go?
So
I'm sure it's right there. B-E-E-F. Right? I'm glad that you held to your convictions. Okay? Just because I'm the clown on stage doesn't mean I know a dang thing. So, that did make a difference. Now, one of the things I also saw in this Discord, right? So now I have like a path of interacting with this thing. And I did it here in Python. I have a way of Python not being stupid slow. And I can pretty quickly iterate and debug this, right?
So this is the setup I have currently right now.
This is what you have right now, and it's awesome.
No, I have a lot of complaints. So I'm moving like 3 bytes at a time into the address of where REX is. Is there a better way of doing that? Well, that's what I'm doing right now, and I think that's very tedious.
Okay, so the statement is I have this set up, and I have complaints. This is horrible, right? Because I have to move 3 bytes at a time into the address at REX.
Yeah. Is there a way to just, if I have already compiled Yonko through like a disassembler emulator or whatever, can I just put all of the bytes like into REX? Would that work?
You know,
I tried.
no. You tried what? Tell me what you tried.
I tried doing something similar to that and it didn't work. And I don't know if I have a flawed understanding in how to get this thing running. So
Okay. So this is where the magic of computer science, right? Can save you. Because if I understand, you're saying, hey, I got this. All right, cool. I can get some bytes in here. But the way I'm fixing this is I'm doing let's say 00 beef, and then I'm copying this, and I have this instruction, and this is, I don't know, 1337, and I now have to like hand do all this, and it's all embedded constants. Yeah. RA or
In the
add RAX3. Yeah?
Yeah.
You're doing something like this.
Yeah.
Okay. What is the name? There must be a better way.
Yeah.
Yeah.
There must be.
There must be, right? If only computers had the ability to loop. Exactly. If only we had the ability to write a loop in assembly, right? This is why I told everyone at the beginning of the semester you need to have some understanding of assembly. It was for this challenge right here, where we have to discover the for loop for like the 100th time.
Even for loop,
But even if it's for loop, you need those new bytes, 3 bytes in each loop. Right?
Yeah, that's also good.
I need 3 bytes each loop.
Few bytes. No.
Like
Three
every
new
time.
bytes.
Well, I'm feeding it new bytes every.
All right, we got a hand. Hopefully there's a thought.
Store the bytes as sets of threes in an array in Python, and then you can.
Whoa. All right. Okay. You could. All right. I don't hate it. The statement was you could store the bytes in an array in Python, right? And then you could, since this is an F string, right? You could generate the hard-coded values for every item in the array and deal with it as a complex format string.
Yeah.
Right? You could do that. I don't know that's where you're going, but I'm going to just pretend that is, because that's something that would work, but it still isn't what I do.
I was gonna go to a loop, but
Oh, you're going to go to a loop.
yeah,
Okay, how are we going to loop this?
like make the loop in assembly, but have the array be in Python so that you can index.
So if the loop is in the assembly,
Yeah.
right? So this string only exists in my Python, right? And so if the array is up here in the Python, I can't access that
Oh yeah.
in the assembly because I'm dumping it to a
I
file.
guess I meant that string.
Yeah, you meant the F string thing. Yeah. I was pretty confident that was what you meant.
Yeah.
So we could do this, but there must be a better way. So I'm going to have Yarn code. What should my yarn code equal? It's going to be some byte string. I have to think. Why am I thinking? X133. No, let's do B fleet. B fleet. And then what else do we want? Dead beef? Okay. I have to remember how that works. No, so that is probably not 16.
8 bytes.
If we look at pack, there is a word size can be all. That's what I want. Because then I don't have to worry about how long it is.
You have to pass Indian as a little.
What's that?
A little Indian.
I don't have to do anything.
Um,
It knows that it's going to be Little Indian because I set the context architecture to be AMD 64. You saw Indianness none here, right?
Oh, I generally pass it.
So being explicit is good. And so like I wouldn't say don't do that, but it's not necessary in this case. Now I'm doing this just to have something that's multiple bytes, right? In length that is my yarn code. How you generate your yarn code is hopefully something that you've written in Python, this yarn code assembler. And so now you can easily generate that yarn code and just import yarn code assembler, write some inline yarn code here that gives you some byte string, right? Because you did that because I told you to do that at the beginning of the semester, right?
The perfect world, that would be.
In a perfect world, I live in a perfect world, all right? I know you guys did, and so I know you guys got this. So I have my yarn code here. Now, my problem is I need my yarn code bytes to be in the assembly. Can I do that?
Say yes.
Yes. Otherwise, like, why would I ask, right? So I'm going to have yarn code bytes be a label. And then I'm going to... Ooh, what do I want here? Let's put a knot. I like this. I did this trick before, I think. So now, once I have my payload, I'm going to concatenate. I'm going to call it Yoncode bytes because that's more accurate. I can just smack that onto the end there, right? And so what I have now is a hex 90, because that is a NOP, followed by whatever my assembler generated for Yoncode bytes. Can I access this location in my assembly?
Yes.
Yeah.
Yes. The statement was yes. I'm going to use, where am I? Now I am here. This is where I wanted to do this stuff. So let's move into, what do we want? RBX? RBX feels good. Except I don't want move, I want LEA. The comment was RIP plus Yoncode bytes. Okay. Can I write a for loop? All right, how do I write a for loop in assembly?
You put a label and you go
All right,
compare it then and go to label.
top of loop. What's my terminal condition here? F. FF? Okay, so I need some counter. We'll move into, sure, RCX 0.
Sure, you want to use RCX, but like for some assist calls RCX where you get manual run.
It's a good question. So statement was, am I sure I want to use RCX? Because RCX gets mangled when you perform syscalls. Well, I'm doing the syscall here, and then I'm doing the syscall down here. Do I need RCX to persist across a syscall boundary? The answer is no. So it's not going to break me here, but it is something to think about generally, right? If I was performing a loop and then calling a syscall, then I would have troubles. All right, so I have top of loop. What do I want to do? I want to move. Do I need another address? No. Let's move into, yeah, we'll just keep this pattern. RDX, whatever is at RBX. All right. And then we're going to move into I'm covering myself up. Can I make this? I'm just doomed to cover myself. I'm sorry. All right. So what is this move is grabbing from RIP plus Yoncode bytes and putting that value into RDX. Where do I want it to go?
To where REX is pointing.
Where REX is pointing. So we can send that to where REX is pointing. And then what do I want to do? How much do I increment RCX by? By 3?
Wait, R6 or REX?
RCX is my counter.
By 1. And then increment REX by 3. So R6 1 while REX is 3.
You want this?
Yeah, since if you actually no.
So this is I get why you say 3, because a Yoncode instruction is 3 bytes. But I'm not moving this in chunks of 3, am I?
Yeah.
Well, what are the increments that I'm moving this by?
8 bytes.
8 bytes at a time, right? And so I probably want to increment my pointer by 8 bytes. And then I know REX and RBX are my pointers. So then I inc RAX. What is my comparison? RCX.
Or we can compare that RCX.
You want it with FF?
No, not length. We could wait, what's that? Yeah, total number of bytes.
Okay,
By
so
8.
total number of bytes divided by 8. All right.
It's 256 divided by 8.
What is 256 divided by 8?
It's
32? Yeah. So 96. 96 in decimal is what we want to stop. So almost that next.
no.
Well, because you have up till FF instructions.
That's 256 bytes.
So you 3 bytes per instructions. 256 times 3, and
wait,
divide that by 8. And then divide that by 8.
56 bytes.
256 is
56
But you're loading 8 bytes at a time.
yeah, that's why you divide by 8.
Instructions 3 bytes. FF, what is FF?
256 divided by 8 is 32.
Well, okay, we agree that 256 divided by 8 is 32. But I think this man is on to something as well.
So then the 3 and then divide by 3? Or
Well, you have
So,
instructions.
we have
Each
F-
instruction is 3
We have FF yarn code instructions,
Yes.
Okay.
which means that we really can write, and a yarn code instruction is 3 bytes. So we can really write FF times 3 bytes.
Yeah.
But since we're writing 8 at a time, right? So we can just let Python do the hard work. All right. We have FF times 3. We divide by 8. Huh.
Yeah.
Okay.
You want the brackets.
What do I do?
It's
You
what's
want the
the bracket?
brackets, it does the
That's good enough, bro.
Yeah, no, I'm okay with that. Right? I'll take 96.
Yeah.
Right. The problem is what happens.
What happens?
Yeah. So if I do divided by 8, FF times 3, why does that have a fraction? This should be,
device.
Because it does
It
divide
divides
first and
divides
then
the
multiply.
end.
If you use a bracket,
if I use a bracket,
Yeah, correct. Like if you
And
parentheses,
this is multiplication.
yeah.
you want this. All right.
Yes.
It fixed everything.
It's like
Yeah, you want double slash for integer division. But that's not really where I was what I was going for there. The page that's mapped is hex 1000, but only so much of that is usable. So one of two things we ran risk of. Okay, either FF times 3 is bigger than a page, which it is not, at which point we would overwrite and we would segfault, or which we have this case where FF times 3 is less than a page, and there's just some bytes that we would write that don't matter for this context. So we're actually perfectly fine with 96. All right. So I want to compare this 96. And then what?
jump less JLE to top of 2.
Is that what I want?
Yes.
Jump it.
96.
That's very
We need a 96. Yeah. But we started 0. No, it's just jump less than.
This?
Yeah, because it started 0, right? So it's 0 to
JLT?
96.
There you go. All right, I'll go with this. We'll see what happens. So in theory, we're going to loop through this starting from 0. Yet for loops still work that way. So it wasn't less than equal. We'll go for 96 iterations of this, writing 8 bytes at a time, which will be just over the 3 times FF that we need. That is going to load all of our memory. Then we trigger the ioctl. Now there's still something wrong here.
No.
What is it?
Is it the X90 that gets written into?
Okay, so there is that hex 90. It's going to cause me some grief, isn't it? How do I fix that?
You can start the
Remove the
bytes.
Say again? So someone said what? Remove it?
Yeah.
Okay, so that's not going to work. Or if it does, like, I will feel bad.
Oh, yeah.
Oh, it does work.
When you send
Oh,
it,
you
it might
have
get
to
in.
send it.
That's kind of cool. I seem to remember the compiler complaining that you had to have something after a label, but I guess not. All right. So sometimes the simple answer is the right answer. That's why I had to have the NOP. All right. So now we have that. All right. We still segfaulted. Take a look at the D message.
I think you passed it.
You passed it.
It's right there.
Oh,
Honest.
Yeah, B.
I got B.
It's starting.
I'll just look at the top.
Instruction pointer 62. So it's grumpy about something. So I think that's it actually executing, right? Doesn't it still loop through?
Yeah, if it counters, if it encounters an unknown register after unknown like up code, it like just does this.
Aw, that's sad.
Also, it does this if it satisfies 2 or more
yarn instructions. Like if an operand satisfies both IMM and add, it will do this.
Oh, okay. So you have some idea of what happened. My claim here was I successfully wrote a for loop.
Yeah.
All right. Well, so see, you agree? 4 years at ASU, you can identify a for loop.
Yeah.
I like it. So hopefully this by using just where's the meme? Where's the meme? Come on, meme. By writing good code, we can save ourselves the pain of doing ridiculous brute force work, right? And like this skeleton, like this framework of what I have written here is something that generically works for this problem of M-mapping and ioctly, right? Maybe in level 2, I have a problem that's slightly different. Level 3, there's something that's slightly different. Okay. If I need to change my yarn code, is that easy to do? Yes, right? Use programming as a tool to save you the pain of hard coding things. Does anyone have any questions about what I did here? Or was it a good YOLO demo?
Good.
Was it a good YOLO demo?
If you put that now, you could potentially have our post to yarn bytes as yarn bytes, right?
So what I was going to say, all right, and until you guys one-upped me, all right, I had an equally just like, duh, solution. but you beat me, all right? You beat me on this one.
Yarn bytes plus 1. Load effective address of RBX starting.
Starting yarn bytes.
What happens if I add 1 to account for that? Right? It turns out I could just like start this whole thing at the next byte and then life would have been great. But I totally agree that if the assembler will let me, let's just keep things at nice multiples a day.
It might give issue when we try to send the payloads, because I did try for previous modules to send it without the knob, and it gave us like
I seem to recall the assembler, so it wouldn't be when you send the payload, it would be this ASM call that would give you grief. So the fact that we made it there is impressive to me.
Also, RX is the address.
Yeah, I don't think you'd want to increment that.
Yeah, you don't want to increment RX because if you increment
Oh.
RX, the first byte would be something else, and that
No. So it wasn't REX, so it's what, RBX, this thing. That's what I want.
yeah.
There we go. All right, one of them goes up 1. Maybe I make the other one go down 1, and then it still works. All right. The point is that you can easily do that, but just making there be no NOP is the superior, most straightforward answer. All right. Are you good as far as your conversation things you were thinking about?
Yeah, I definitely, as always, like overcomplicated and was trying to like retrofit a method that worked for me to a different challenge, basically.
Okay. Like that's a common problem. Like you're like, oh, I did this. Let's just do the same thing. Try and not make assumptions and just work from first principles. Generally speaking, for years, like I told people to never use shellcraft, but I think this, at this point in the course, I believe you can write assembly. Maybe not a for loop, but I believe you could set up some registers and maybe type syscall, right? And so shellcraft can save you that pain. With that, I'm definitely out of time. Hopefully that was useful for everyone. With that, I'll leave you. I'll see you on Thursday. I'll show whatever the grade distribution is. Goodbye. Good luck. Have fun.